My theme all along is trying to make programming simpler. And then there's this dream that there'll be some breakthrough. Somebody will
Hmm.
figure out some
Yeah,
thing we've missed, right? And there's
yeah.
there's reason to believe that. I mean,
Jonathan Edwards is a researcher who's worked at MIT with Daniel Jackson and later Alan Kay at his research lab. He's been programming since the 60s. Previously, he founded his own startup, which he sold at the height of the dot-com bubble, and is using his exit money now as an independent researcher to further the future of programming. His main research project is the subtext programming language. Its goal is to radically simplify application programming. Building web and mobile apps should be made as easy as using a spreadsheet. To reach this goal, Jonathan thinks we have to radically rethink programming at a fundamental level. One of the most interesting ideas in his research is that calling functions in different contexts is equivalent to a copy-paste operation. So it's basically the same as copying the body of the function to where it's needed. If we had an IDE that could keep track of these copies and manage them for us, we could easily make changes to either copy and then sync those changes over to the other copy. We could then even switch between the abstracted and non-abstracted versions of the code at the press of a button and make changes to either of them as needed. This way, the two versions would really just be different views on top of an underlying data model. We could then even add additional views, for example, a visual programming environment like blueprints in Unreal Engine, and seamlessly switch between the different views. Jonathan built a research prototype of some of these ideas, and he's currently searching for this underlying data model. I think this research is really valuable because in programming, currently a lot of time is wasted on finding the right layer of abstraction for any given problem. For example, people often argue about when to split up a function into smaller functions. The same is true for classes and other abstractions. If these were just different views and not actual changes to the code, a lot of decision making on how to correctly organize your project could be simplified. Jonathan's research is absolutely fascinating, so I really hope you enjoy this conversation, and please consider sharing it with a colleague if you do. What's your current research about, and what is the thing that excites you the most at the moment?
my theme all along is trying to make programming simpler. And I can argue forever about why programming kind of sucks. It's just way too complicated. And I've always known this. I mean, ever since I first started programming, I realized, this is just too complicated. It's unnecessarily complicated in many, many ways. And I always had this intuitive feeling that, we're sort of in the Stone Age, right? And, it's a brand new thing. I mean, even now, it's only been around for 50, 60 years, right? And we're kind of still doing it the way we did it 50 years ago, right? So it's just we sort of arbitrarily started doing it certain ways, and it's just very primitive. And I'm not sure why everybody else doesn't see it, but I've always seen it, and it's very, very annoying to me. I mean, it's just programming is my life essentially, has been my life, and just to spend your life working on this stuff, which sucks so badly and could be so much better. Just as an engineer and a theoretician, I find it really troubling, and I want to fix it. So, I mean, that's my story, I guess.
Whenever I talk to people, they always have different reasons for why programming sucks. So tell me, what do you think? Why does programming suck, or what are the things that suck?
Well, I don't think there's any one reason for it. I think it's a bunch of reasons. Um, I mean, part of it is just, historical accident that, we've seen this over and over again, that the first thing into a field takes over, right? So whatever arbitrary, silly mistakes you made the first time out seem to stick. We don't seem to have any process of creative destruction in software. We never throw anything away. We simply build a layer on top of the old thing. So we have a lot of well, technical debt is the official term for it, right? Which we've built up over decades of technical debt to the point where it's almost all technical debt, right? So I mean, so that's sort of an unavoidable thing, and the only way you overcome that is if you consciously invest a lot of work in fixing that technical debt, right? Um, and it's something that we as a field don't do. As a young field, we're very immature, and we really don't have any, institutions thinking about the good of the field, right? The good of all programmers, the good of future programmers. No one cares about that, right? Nobody's investing in that. Other fields do, other engineering fields do. They have national and international organizations that attempt to improve things for everybody. We don't have that. There's simply no one anywhere working on that except for a few weirdos like me, right? So we haven't, as a young field, we're still very immature. We haven't built institutions to try and fix things. But there's worse parts of it too. It's not just that sort of inevitable technical debt. It's also that we've made a lot of really bad decisions for bad reasons because we're bad people. Um, I mean the and I'm talking about myself. I've made some real messes just because of sort of intellectual arrogance and um, self-satisfaction. It's just programmers, we're working in this arcane stuff that nobody else knows about. So it's really easy to bullshit, right? And simply do things to make ourselves feel good, right? One of the biggest current examples is, JavaScript front end frameworks, where there's this incredible churn, and it's mostly just kids saying, "Oh, I want to do something cool and interesting. It'll look good on my resume. It'll be fun. I'll learn something new." But if you're an engineer and you're getting paid money to build something for somebody else, that's extremely self-indulgent and irresponsible to, adopt crazy new technologies just because you think it'll be fun, right? But that's sort of the ethos. We don't have a very professional attitude. Professional, we're not professionals. We're it's sort of accepted that it's okay to just have fun and fuck around, at the customer's expense. And so we've built all this crap. And I did it myself when I was younger, so I'm speaking from experience. And so a lot of our problems are self-inflicted in that way, that we're simply making decisions for the wrong reasons, because we're acting. And part of that is just that programmers really are young because the growth of the field has always been accelerating, and therefore it's always gotten younger and younger on average. There's very few old programmers because there's always more and more people coming in, and so the average age keeps going down, right? So, the average age now must be in the low 20s or something. And that's just, 20-year-olds have a different attitude towards decision making. Other fields that are sort of more mature and slow and aren't growing so fast have old guys like me, been through things and, or can, try and make some wiser decisions. So we don't have, and in fact, we have the opposite effect, is that someone who's old is sort of automatically discounted right there. Their opinions are not considered really very good because they're out of touch, right, with all the latest fads. We simply haven't figured it out yet, right? And here, this is the interesting part, because I can't change society and I can't change people's personalities, but I can try and discover new ideas and popularize them. And we've sort of just gone with, like I said before, we've gone with the first cut on everything. And we haven't really sat down and tried to figure out alternate paths. There's so many other ways software could have evolved. And there's a lot of interesting research there, a lot of interesting questions. Could we have done things differently and made them simpler? So I find myself trying to answer that question a lot. And then there's this dream that there'll be some breakthrough. Somebody will figure out some thing we've missed, right? And there's reason to believe that. I mean, because there's just so much about software. When you look at this incredible, we call it a stack now. We actually call it a stack because it's just this giant stack, right? But there's so much repetition and, it's just variations on a theme over and over and over again. Why isn't that one thing, but we don't frankly know how to boil that down to one thing, right? There needs to be some sort of breakthrough. I've always believed, and so I've been working towards that, some fundamental breakthrough that kind of unifies things. On the other hand, working on a grand unified theory of software is sort of a prescription for failure, right? Because it's you can keep working on it forever and never get anywhere. So
That no, but I completely agree with you. I think there are big benefits that are still there to be unlocked, and it's like I do think I do think there must be something better than what we currently have, and it must be revolutionarily better, like significantly better than what we currently have. I think that's I can feel it in a way. I don't know what it is, but I can feel it as well. But
And I agree. And it has to be, because that's the only thing that will change anything, right? You know, if you say, well, I could make programming 10% better, no one cares, right? Right. It's got to be like 10 times better. That's, you've got to get something that's such a radical improvement that it's worth starting over again.
you mentioned before this JavaScript situation, which it's awful, like this whole JavaScript framework situation. I cannot imagine how it must be for a young person to learn all this JavaScript stuff from scratch nowadays. Like, it's not enough to just learn JavaScript, right? You have to learn all these paradigms. You have to learn about the virtual DOM and so on and so on. So I can see the craziness in this, but at the same time, as you said, we haven't uncovered the thing yet, right? And I completely agree with you on this. In my opinion, there aren't really any best practices in software because we just haven't done this enough. Like you said before, how long have we been doing construction, like construction of buildings, right? We've been doing this for hundreds or even thousands of years, right? So this is like a super fresh new field. We haven't really established any best practices. So isn't it also in a way a good thing that people are trying new things and that they are coming up with these JavaScript frameworks? Because I think, yes, they are all very similar, but there are also always some cool new ideas in there, right? Like, you could argue that React and Svelte are almost the same thing, but also they're all not exactly the same thing, right? Like, Svelte came up with the whole compilation idea, which is better for performance, and so on. So how do you feel about that?
Well, I mean, I agree. I don't want to argue against innovation and experimentation. I'm all for that. You know, we need to make things better. Um, and so, you know, but a lot of the variation there, I mean, React is a good idea. But all the other things that are just slightly better than React, I'm not sure it was worth the energy, right? I don't really get that. And React's an interesting case because there's actually some really nice, clean ideas at the heart of it. And you know, and also I have to give credit to Evan Zaplicki of you know, Elm, who actually I think is the person who really first invented the idea of React, um, that's behind it. But the thing about React is that it's a programming language screaming to get out, right? What they've done is they've hacked it in with all of this grunge in JavaScript in order to invent a new semantics living in the DOM and on JavaScript, and it's just full of landmines and pitfalls. And you know, if you know, you can break it so easily if you do the wrong thing, because it works just by, oh, well, you just have to know how it works internally and be very careful that everything you do doesn't mess that up. It should just be built into a programming language where that semantics is wired in, right? You can't break it, right? It's just wired in and it works. But no one has the balls to do a new programming language anymore. No one would adopt it, right? It has to be on JavaScript in the DOM, and therefore it has to be just an incredible complicated mess. So, you know, what do you do about that? You could, and what's sad is that I don't see people inventing that language, even for as research, right? There's clearly a language of that computation and display model, and ask, you know, like I say, begging to get out. But it is so against fashion now to try and invent a new programming language that no one wants to touch it.
But couldn't you argue that Elm is that language?
It partially, I think, well, I don't want to criticize Elm because I love Elm. Elm is, it just has so much of the right attitude. Just the way that the other thing that Evan pioneered was nice error messages,
Oh yeah.
right?
Oh, that's so
Right. We've
great.
had,
It's
I mean,
wonderful, right?
languages have emitted these incredibly hostile error messages that are only meaningful to the compiler writer, you know, and it's just awful. And it's always been awful. And Evan said, no, actually, it should try and explain things to the programmer. like this is an incredible invention to think that you should have error messages that are meaningful.
I am so surprised. No other language that I know of has adopted this. I haven't done any Rust programming. I think Rust kind of has tried something like this. And it's so, you're absolutely right. It's so fantastic. If anyone else is watching this and you haven't tried Elm, look at the error handling in Elm, like at the compiler errors in Elm. They're fantastic. It's really incredible. I don't understand why nobody else has stolen this. Like
Well, like I was saying, Rust has followed the lead there somewhat, trying to improve it. But I think, for this programming model for UI that could be built into the language even more fundamentally. Elm is basically ML, right? And you can push further on having this computation model built into the language. It's yeah, I just think it could be done better, but I love Elm, and unfortunately, Elm is suffering under this problem of it being another language, right? And I think, I don't want to speak for him, but I think he's sort of given up on a lot of on convincing sort of the tech bro programmer people that hang out on Hacker News and stuff, to use Elm, and he's sort of trying to go over their heads directly to, more beginner programmers who just want to get something done without being a virtuoso. And um, so, best of luck to him. I really hope he can do it. Elm is a great shiny example we should all follow.
yeah, I agree, and I think that Evan's talks are also really fantastic. I really love watching those. Why do you think that Elm did not succeed? Or let's say, I mean, Elm is in some ways successful, but like, why is there no wider adoption for Elm?
Well, Evan did actually give a talk about this himself a year or two back, and just about the I'm sure I can't do it service. I mean, you should just watch it because he's a great speaker also, if you haven't seen it. But a lot of it was about the economics of language development, and basically it takes an incredible amount of money, and unless you have some super tech company like Google or Facebook funding it, it's really hard to get the work to pay for the work, because it's hard work, and open source volunteers don't want to do the grungy hard work that necessarily is needed to build a production quality language. Documentation and features and fixing the errors. It's hard work, and you need a lot of money.
I think it's not just they don't want to do it. It's also just it's really like you need a lot of knowledge, like in a lot of like you need very deep knowledge and also very broad knowledge. Even like it's really difficult, I think, to do this kind of work, right?
And it's also, I think, Rust is done very well, but Rust is targeted at, you know, extremely talented systems programmers, right? And these are exactly the people you need to work on a language, whereas Elm is targeted more at application programmers. At least that's what we used to call them. I don't think there really is a widely used term now for the people that, are just building software. They're not particularly care to be expert super programmers, right? They're just doing their job, and they're working at some company, building some applications. Those aren't the people that work on compilers, though. So it's much easier if you have something like Rust that appeals to the same people that will build a compiler. And that is one of the paradoxes that we've built a lot of our technology for our own purposes rather than for other people, like application programmers or end users. Certainly, the open source model works really well for things like Linux and Rust, and not so well for end user, more oriented things.
My answer to why Elm isn't that successful is that I've tried using Elm quite a lot actually because I like the language so much because I think it's such a cool idea. But then I always end up going to something else because there's just not that much stuff out there. So I find like And Evan talks about this in his talks as well. Like, how important is it to actually have an ecosystem around language? Like, and he says things like, I'd rather have like 3 good libraries than 100 awful libraries or not that great libraries, right? But I'd love to agree with this. But it sounds like it should be true, but empirically somehow it's not. I don't know why, but empirically I found it very difficult to actually get work done in more niche things. Like, it feels like just having this gigantic mass of people. Like, you can see this in other things too right now. Like, for example, VS Code, for example, is for me a good example. Like, VS Code, why is VS Code this good? And I know there's a lot of people hate on VS Code nowadays, but I think VS Code really is in many ways really good. And it's just because you have this army of JavaScript developers that start building plugins for everything. And so I do think that this ecosystem component really helps with that. Would you agree, or what's your
Oh,
viewpoint on this?
well, I mean, to answer your question, in my day-to-day programming, programming in VS Code, in TypeScript, and
Okay.
React. All right. Right.
Mhm.
And I mean, I had to get over a few years ago when I switched to TypeScript, like, okay, where are the collection classes? You mean everything's an array? But okay, everything's an array. It's like I can live with that, right? Being in the mainstream is the most technical feature, right? It overrides all other features, right? If you're in the mainstream, that means that all your problems somebody else has already had, and you can just go online and everybody has software you can steal and reuse, and just the support, the tooling is going to be better. I mean, like, the Chrome developer tools are amazing, right? It's great. I mean, the DOM sucks. It's just an awful nightmare of a user interface, but they've invested, I don't know how many hundreds of millions of dollars in programmer time to at least make it workable, right? And there's workarounds for everything. So um, I've worked in little niche languages and environments in the past, and it sucked, right? You always felt alone on your own, and being in the mainstream, it's annoying, and you can curse it out, right? But there are solutions to your problems, and you can get work done, right? So I don't have a good answer for how we overcome the fact that being in the mainstream is more important than anything. And I mean, my answer is that we can't overcome it. That for the kind of programming that we're doing today, the existing technology is it, right? We will not in any of our lifetimes displace that. The only way to make progress is to open up new areas, new kinds of programmers, and I always keep talking about application programmers and end user programmers because they're very poorly served by the current tech stack. It's very much oriented to the people working at the big internet software as a service companies. And it suits their needs pretty well, but really not anybody else. So if we can carve out a different market for a different kind of programming, that's possible, maybe, to make progress. But we'll never displace the current stack for the current kind of programming, I don't think.
Hmm. So, to rephrase what you're saying that we need to basically come up with this revolutionary new way of programming, and that will hopefully then like start a new group of programmers that will grow and grow and grow, and then at some point maybe replace the current mainstream. That's kind of what you're getting at,
Well,
right?
this is the classic disrupt from below strategy, right? Which we've seen play out many times. You build a toy for people that are just fooling around and doing something unserious and unprofessional. And it just turns out there's so many more of those, right? I mean, professional programming is really not that many people, right? And if you could really come up with something that let other people program that didn't have 5 to 10 years of experience, right? That would be an overwhelmingly large market that could then grow because of how big it is. So that's the only way you disrupt from below. Initially, it should be seen as a toy that no professional would use. And then just because of the masses of people that end up using it, it gets better and better, and then eventually encroaches on the previous high-end professional stuff.
Right, and it's like with scientific revolutions where uh, it is said that usually it's not that the old people are convinced of the new
Right,
thing, but really that they die off and are replaced by the other people. Yeah.
right.
Where do you see the big potentials for improvement?
Clearly, we have to collapse the stack. I like to point out a couple of data points. If you were to print out all the documentation for the software it takes to build an application, right, from all the way down from the operating system all the way up to the UI frameworks, everything, right? You print it out and stack it. I mean, it would be, tens of meters tall, right? It's just no one can hope to ever know all that, right? It's crazy, right? The best you can do is get a feel for the important parts of all that. And that's why it takes at least 5 years for someone to become sort of a competent full stack developer, right? And, in experts, more like 10 or 15 years, right? But there's so much. Just think how many kinds of if statements are there in this stack, right? How many different ways to write an if statement there are? There are everywhere, right? The shell, every language, there's, XML forms of it, there's template forms of it, there's just over and over and over again. Surely we don't need to have 100 different kinds of if statements, right? And what really gets me though is the data models. Why is it that we have programming languages have certain kinds of data? In fact, there's bifurcation in programming languages, right? There's between the OO imperative languages and the functional pure languages, which it's a graph of objects versus a tree of values. But then databases have a completely different data model, right? Tables and relationships. And you use a declarative query language to get at it, completely different from a programming language. But what's the difference? Why should the data, because you want the data to last after you turn off the computer or stop the program from running, why does that mean it needs a completely different shape and a completely different tech stack, right? There's an enormous tech stack on the database side, even bigger one on the programming language side, and it's like you have to struggle to talk between them. It's this problem is called the impedance mismatch problem. It's been talked about for ages, and that's always just struck me as crazy, right? Right. We have to fix that, but we don't actually know how to fix that. This is actually a research problem. You would think that at this point in 2025, oh yeah, there's various technical reasons why these data models have to be different. But if you didn't care about performance, it would be straightforward to have a shared data model. We actually don't know how to do that. So to me, that's one of the most motivating things is how can that be an open problem still, right? We need to figure that out. And then I say, oh, okay, well let's keep going on that. Like the operating system, the file system. Why is a file system a completely different thing yet again from what lives inside the programming language and what lives inside the database with its own set of APIs and its own weird semantics? And then let's look at the UI, the DOM, right? The DOM was a really good, you know, unintentional breakthrough, right? That's like maybe the most important thing about the browser, and it was just an accidental implementation feature. But the DOM turns out it's really good to have a data model in your UI, really useful. Yet it's not the same data model. It's yet a new data model, right? That's kind of a cross between objects and a tree. So, so to me, data is upstream of code. And so that's why I'm focusing these days on trying to fix this data model issue. Let's just have a single unified data model. I mean, there's compromises you're going to have to make, probably performance, you don't have to worry about it first, but at least conceptually, there ought to be a single unified data model that works for all of these. And of course, a single language on top of that that works. And then, wouldn't it be great if the one language that you use for, your algorithms, you use it in your database, you use it in your UI. It would be nice.
You just said a key sentence. You just said data is upstream of code. Can you explain this a little in a little more detail? What do you mean with this?
It's really fun to think about programming language design, right? And so, I spent years just trying to play around with, let's just come up with a better programming language, make it more natural, more natural semantics, programming by demonstration, blah, blah, blah. But, it's the data that really has the value to the end users and the application owners and all the stakeholders and stuff, right? They don't care about the code. We as techies care about the code, and we'll obsess about programming language features and, oh yeah, you got to go to Haskell because higher kinded types are so cool, right? That's bullshit, right? That doesn't make any difference for the application, right? And I've always realized that if someone put a gun to my head and said, you've got to get this software working and here's a Fortran compiler, no problems. I could make it work, right? You know, but the data is where the actual value is. And so if we can do solid, valuable improvements to data handling, that filters through to benefits, right? That are more than just making programmers excited, right? Because we can't just please ourselves. If we want to change the world, we have to provide value for other people besides programmers. I've kind of given up on programmers. That's another side thing is I've given up on professional programmers because there's this thing called expert bias. It's a cognitive bias, but it's kind of deeper. You know, the reason that we're so successful and we get paid so much money is that we're experts at this incredibly complicated technology that most normal humans can't handle, right? So we're this weird, mutant case of people that can handle this. And we don't want it to be simpler, right? That would be actually a big loss of power, status, and money for us. So I realized after a while, why aren't programmers, interested in making things simpler? It's because it's not in their interest to do so. So we have to, if you want to sell simplicity, you have to go over the heads of the professional programmers. So I've sort of took me a long time to realize that I myself am not the market here, right, for these new ideas, because people like me don't want these new ideas. It's sad to come to this realization. It was hard for me, and I really kind of felt bad about it, but
I definitely see this kind of resistance a lot against these new types of ideas, but I wonder, or like I think I disagree with you that it's not because most programmers don't want this simplicity. I think it's that I think they do want that. I just think it's that a lot of them forget how difficult it really is to do programming. I think it's so. I see this all the time because now I'm teaching complete beginners, and I see this all the time. It's insane how difficult it is to learn this. Like,
yeah, it's so this is the expert bias. It's actually, a well-known cognitive bias that you can't remember what it was like to be a beginner. Once you become an expert, you take it for granted. All those years you spent building up your expertise, and it's obvious to you, and you just can't see the fact that beginners don't get it anymore. And so sitting down with beginners is really eye-opening. They and then you see all this stuff like, okay, so here's the thing. Almost no programming languages have keyword arguments to functions. You're expected to remember the order of the arguments. It's just the order of the arguments, right? You have 5 or 6 arguments to a function, and you're just expected to memorize what order they come in. That's like stupid, right? That's like insane, right? Um, and we just take it for granted that that's the way it is.
which is why it's like really difficult to program without an IDE or some tool that
Yeah.
tells you, right,
Right.
the
Yeah. And
argument
now
order.
VS Code
Mhm.
actually now hints in the names of the parameters for you, because the language doesn't support it. But yeah, so there's just so many things like that are we just kind of technical hurdles, and they really are problematic for beginners. So that's part of the problem too, is that And it's taken me a long time to come around to realizing that simplicity doesn't sell for just all these reasons we've been talking about. If the if what you're doing, if the benefit of your research, of your new idea is to make things simpler, no one's going to give a damn, right? Because the experts don't even aren't even aware of it. It's not even in their interests to use it, and the beginners don't know, right? They don't actually know that it's any simpler, and they sort of take the experts' advice. They want to follow whatever the experts are doing. So it's you can't simplicity doesn't sell. You got to come up with a different benefit. And so I've been focusing on data as ways of delivering benefits that are clearly that people can see.
Now let's talk about that a bit more. So you already mentioned the object relational impedance mismatch, right? So let me ask more broadly, what's wrong with data currently? Like what could be better?
Well, I mean, the idea of having a single unified data model to me, theoretically is very motivating. And I've hitched on one idea, which is version control for data. That I think is maybe sort of like a wedge issue that could really help. Um, we have version control for code, and I'm old enough is that I used to code without version control, and um,
It must have
and you
been
just made
horrible.
yeah we didn't know any better. We
Yeah.
just didn't know any better. You would make
Mhm.
copies of things. Oh, and also I worked in operating systems like VMS where it automatically saved versions of files for you. Like all files were versioned, and it's just something that Unix didn't include. Many operating systems before Unix had this built-in versioning on files, and it just got
Wow.
thrown out with Unix, and now everyone's forgotten about that. It was really useful. Anyway, so you had that level of versioning, but still, it wasn't fine-grained. Now we have version control, although I could rant about Git also. Git is, yeah, let's just not even I mean, Git is another one of these self-indulgent things. It's right. It's a tool designed for the top 1% of programmers who, are, dealing in massive repos and having to handle pull requests every day. That's just not normal programming. And the tool's not designed for normal programmers. But anyway.
90% of the videos on my channel are about learning Git, so and trying
Oh
to
yeah, there you
get
go.
to know
There you
Git
go.
a bit better. So yeah, it's a really difficult tool.
Yeah, and I don't know if you've ever run into Gitless, but my office mate at MIT, Santiago Perez, did his research was this Gitless tool, which was like a wrapper on Git to try and
Oh, cool.
clean it up a little bit. Anyway, so version control on code, we can't imagine living without it, but everybody else lives without it on their data. And I use this one example. If you look at one of my talks, I use it all the time called Frida, which was Margaret Burnett's in one of her papers. Um, just people working in spreadsheets, and they're emailing their spreadsheets around to each other, right? And you get all these variants of the spreadsheets, and you want to compare them and you want to reconcile them, and that's a completely manual process, right? And this is something that happens on a massive scale. Everybody that uses a spreadsheet is involved, has all these variants, and they're named like, March, year, whatever, and people working on data notebooks also end up with directories full of all kinds of versions, experimental versions of their notebook, right? So we should have version control tools on these things, but fine-grained version control.
Couldn't you argue that Google Docs or like Google Sheets or something like that solves this problem? I mean, I understand it's
No, it doesn't, right? I mean, it lets you have multiplayer collaboration in real time, but what happens is you get variants, right? Things fork, right? People take a copy and adapt it for their own needs, and then you want to share some of those changes. And Google Docs doesn't do that. You have one copy that's always the same, you know, after a few milliseconds, it becomes the same. And it doesn't have branching and diffing and cherry picking and all the things that we expect for version control.
so it's like, for example, this example you showed me in this other video, right? Where basically two people are working on this document, but like one person needs to update maybe the styles in the document, and the other person is working on their own version, but they are changing the data, And then kind of like, how do you reconcile this, right? This
Right.
is something you cannot currently do with tools like Google Docs and similar, right? That's what you
Right.
mean.
Yeah. So Git for spreadsheets, but which lets you, intelligently handle things like in the case of a spreadsheet. I mean, this is schema change in the case of a database, but on the spreadsheets, it's like adding rows, adding formulas, dragging a whole region of it over to someplace else. These are all high level changes that you might want to propagate, cherry pick, right, between branches. And we don't even know how to do that. So much less having tools to do it. So that's my research for the last few years has been how do you do this kind of very general purpose version control, fine-grained, high-level version control on typed data, structured data like we have in a spreadsheet or we have in a database. And if we could do that and make it usable, unlike Git, right? That seems to me a benefit, a solid real world benefit that normal non-programmer people would appreciate. And I think we have to, whatever we're doing under the hood to make programming better and simpler has to come packaged with these benefits. Otherwise, it's just never going to exist, right? We need a vector to infect the world.
Hmm. So what's your vision here? Like, if you like, let's say your research is going great and everything works out, what would that thing look like that pops out at the end? I mean, obviously that's maybe hard to say since you're still in the process of finding that out, but like, what can you say already?
Well, I think the successor to the spreadsheet might be the simplest description. Spreadsheets are an incredible special case. They break every rule that we've talked about so far, right? Their their appeal to end users, non-technical people. They don't use any of the standards in the rest of the tech stack. They're like an entirely different world, and they're incredibly popular, right? So much work is done in spreadsheets. Spreadsheets are the most popular database and the most popular programming language in the world by far, right? But they're singular, right? There's never been anything since the spreadsheet, right? So there's this gap. I talk about this all the time, this gap between what spreadsheets can do. You can only push them so far. And if you want to do something that doesn't fit into a spreadsheet, that can't be shaped as like a spreadsheet, there's this enormous jump to, okay, let's learn Unix and everything else, right? Right. So this gap is the opportunity. And so what I would like to do is have, the next spreadsheet, but something that's more general, more general is the word, right? It's got a real programming language, it's got a real data model. You can do databasey things, you can build custom user interfaces, application programming. We saw a little bit of that in some things like from the 90s, like HyperCard and Visual Basic was a really nice product, and other things like Visual Basic. It really was usable by a lot of people, easily learnable. Um, and none of these things survived the um, transition to the internet. And that's sort of another story as why that was. But um, I'd like to get back to that, the next HyperCard, the next spreadsheet. And if it turns out that it's actually a general purpose programming tool underneath, that's sort of the Trojan horse.
Yep. Yeah. That then takes over, like we said before. Mm.
I don't think I'm the person to do that though, right? I mean, because that's a big job and it's a movement that requires, to make things happen is more than just ideas. But my dream would be simply to come up with some of the seed ideas that make that possible so that other people can make that happen.
You want to lay the groundwork essentially.
The theoretical side of it, at least, the key insights and, build some prototypes which are, you know, very eye-opening and thought-provoking, not necessarily production quality. I have enormous, to get from a researchy idea and a little prototype that's more like kind of sort of semi-fictional, to get from there to a real product that end users can use. There's enormous, enormous gap, and it takes an enormous amount of creativity to pull that off. And it's not something that one person does, right? It's something that you have to have at least a company and more likely a movement, right? Because I don't think any one company really should even try and own this technology. That's going to kill it. If one person is trying to monetize it, it will not succeed. It has to be something that is open to everybody. The other thing I've been working on is not just this research, but it's also community building. I've spent a lot of time, some of it wasted, but I keep trying. We need community that will help us build new things, right? And I keep running into people like you that realize, yeah, we could do better, and I want to work on this stuff, but it's so hard as an individual, right? So we need organizations, places where we can meet and talk and share ideas, but also compete with each other, which is how it really works. So I've been building workshops and conferences and just trying to organize socially for sort of a software counterculture, if you will. And that's got to be part of the solution too. It's not just ideas. It is a social movement of some sort. It's like the live programming workshop is one thing that's is a good place for these kind of ideas. There's the future of coding Slack is a good place for people to talk. And then there's other places that are semi-academic that are meant to appeal to people that are researchers, like the Onward conference and the programming conference.
I'm wondering though, because like I love nerding out about this stuff, and I think, like, to me it's so fascinating and interesting. I would love to actually spend much more of my time on this kind of research. Part of the problem is incentives, right? Like, I would not know how to get funded for this kind of work, really.
Yeah, yeah, it's really problematic. You have to have something else that allows you to do this, um, because the professional academics, that's sort of become I mean, I don't want to say that there's nothing good going on there. There's all sorts of great research happening in computer science, but it's very much focused in certain directions and in certain styles of things, and they don't want to take on these big issues. That's really kind of doesn't fit the agenda of computer science to think about foundational, broad, interdisciplinary stuff. It's just they can't get funded, they can't get published, and it would be career suicide. But there are some weirdos on the edge of academics who are doing it just for the love of the ideas and rather than career success. So I try and hang out with those kind of people, but still, it's tough, you know. So I would say that if you do go the academic, get the PhD, it's possible. You don't have to end up at MIT, right? But if you're willing to compromise on where you end up, you can do more interesting heterodox research by compromising on your career success. But generally, it's a real problem. I mean, most of the people that are non-academic are like me, who were previously in business, right? And so have savings that they can live on, and are deciding to do this as an avocation rather than a career. For young people, I don't have a lot of answers. I've talked to some people that they do consulting for 50% of their time and try and do research for the other 50. But it's hard, and it's hard to build up a consulting business if you're only half time. It's a very bursty kind of business, right? So you're either 200% busy or 0% busy.
I just think it's sad, honestly, that that's the state of where we are at with this kind of, like, because I think it's important research, and I think the papers that I've read from you, they're fantastic, and like, that's
Thanks.
ridiculous that that's not getting funded, right?
Yeah, no, it's impossible to get it. And I'm kind of surprised. I mean, there's a bunch of really rich people, programmers, right? There's a bunch of programmers that have become super rich. And I just don't get why they haven't wanted to turn that money back into trying to improve programming. They never seem to do that. They want to cure cancer or, go to Mars or all these other things, but why, but never, they're not investing in programming.
I would say curing cancer would be a pretty good one.
Yeah,
but
right.
but with
I
them,
gotta, yeah.
yeah. So there
No,
I
I'm not saying we shouldn't
but
cure
yeah,
cancer.
no,
It's
no. But
just
I
like
see
you
what
would
you mean.
think that one or two of them might be interested in programming as something to invest in, but they seem to all. The problem is that official computer science is the, legible form of research, and so if you're donating money, you typically donate it to the things that are approved causes that are clearly good things. So they'll, like, build a computer science building at MIT or Carnegie Mellon, but that's not really doing anything for us, right? But
It's sad because I think like other people, for example, who immediately comes to my mind is Brett Victor. I'm sure
yeah,
you know his stuff, and I think that guy is an absolute genius. Like I,
right, and he can't get funded
exact.
either,
That's exact. Like that's just like
right?
if
If Brett Victor can't get funded,
yeah,
what chance is there for
yeah,
us?
exactly. That's just to me. That's absolutely insane. Like yeah, yeah, I don't know what the answer is either.
Yeah, there's
Um,
always Patreons. I
mm,
support a number of independent researchers that
mm,
way.
mm.
Um, there's this the ink and switch people have an interesting model where they're doing some good stuff and managing to get I don't know the details actually, but somehow they're getting people to contribute money to support that. So there are some sprouts of things happening.
So I feel like I have to ask. Unfortunately, I feel like I have to ask the AI question now,
Right, right,
because so
right.
you
The
mentioned
elephant in the room.
yeah, because you mentioned spreadsheets before, and I just watched this podcast with Satya Nadella, with the Microsoft CEO, because they built Python into spreadsheets now and Copilot and so on. So how do you feel about that?
Well, I mean, the jury is out, right? We don't really know. Nobody really knows, and there's a lot of opinions, but not too many facts. And I don't know anything about AI. I've actually been avoiding it because it's pretty clear to me that the way we're doing AI today is probably quite different from the way we'll be doing it in a year from now. So, I don't really want to invest that much energy into learning it, but it's scary. I mean, I mean, it's amazing what they've been able to do so far, right? I mean, no one thought this would be possible. And the scariest thing is that the researchers themselves don't know how it works, right? And are surprised by it, right? So we don't really know what we're doing. And it's just like we're like messing around, trying things randomly, and some things work and people are shocked at the results. And so who knows, how far it's going to go. And there's certainly a lot of people, if you hang out on Twitter, there's all these AI maxers constantly saying how, yeah, it's already solved, it's over, programming is over, AI is going to replace all programmers, and you shouldn't even bother learning computer science now. You should become a product manager. And I find that hard to believe. Um, it's just programming is really hard, and it's not just that. Okay, so it's something where certain kind of people like us are really good at it because we can think like a machine really well, and so it makes sense that a machine would be good at thinking like a machine. So maybe it makes sense that AI is good at programming, but the hard parts of programming is not, algorithmic design. It's understanding, what the user actually needs and understanding what is different between what they want and what they need, and understanding how what they need is probably going to change in certain ways in the future. And this works really badly even today, right? In my experience in commercial software, it wasn't the technical problems. It was all these interfaces between the programmers and what's now called a product manager, and the interface between the product manager and the actual users, right? And there would be lots of mistakes and misunderstandings there that nobody's at. They're talking across purposes. They end up building the wrong thing. And bridging those gaps requires really understanding a lot about how the business works, about how people work, psychology. And so to really solve programming, AIs are going to have to become really, really smart. Um, so, I mean, it seems to me that having an AI learn how to do carpentry just has to be easier than having an AI learn how to wrangle customers and with different business agendas and stuff and agree on something to build. It's just um, so I just find skeptical that just that programming is very much having to understand people and their needs and what's possible technically versus what works in the business context and what works in the human context. So okay, so maybe by having read everything that's ever been written, it's learning how people think. I don't know. Um, to me, as a, I'm and this is my own personal failing, I was never very good when I had people working for me that I couldn't trust, you know, and weren't really very, very smart and reliable, right? So I don't want to be being a PM for AIs that are sort of like an idiot savant that's tripping, you know, and
That's
that
such
just
a,
doesn't
oh
sound.
God, I love that. That's such a great way to put it.
There are some people whose opinions I do respect that are working with this AI stuff and say, yeah, this is going to be end user programming, right? And that it's what I've spent my life, half my life working on is irrelevant now because we're just going to have AIs do it for us. We don't need to simplify the tech stack. We simply have to invent something smart enough to be able to use the tech stack, right? And then we never have to simplify things. I still think simplification has value. It's just a fundamental value that can't be ignored in the long run, but who knows? It's entirely possible. I wouldn't, I could believe, I would, if it works out that AI does replace programmers, I wouldn't be all that surprised, I guess. I have to say that, I could see that as conceivable, right? I guess that's what I'm saying. But I'm just operating on the assumption that it's not true, right? And that we still need to solve our problems ourselves instead of hoping that the superintelligence will solve it for us. Because hoping that some other, hoping that God will solve your problems has never worked out in the past. Maybe this will be the first time. But, if we invent a God, it probably has a different agenda than solving our problems. I don't know. But what do you think about AI?
I agree with almost everything you said. I also think it's not clear yet what's going to happen. I do think that there are some things that AI will probably never be able to do. And I've tried to explain that in this previous video that I sent you. I do find AI tools really valuable in my day-to-day development work, only for certain things. I've had the experience that they're just terrible at generating code. Like the code that is generated is almost always full of errors, even for relatively simple things. If it's something that there's not a lot of training data on, it's just completely wrong often. And even with a lot of back and forth with the AI, I can't get it to produce anything useful. And some people tell me it's because I suck at prompting. So maybe I just suck at prompting. I don't know. Yeah.
Yeah.
But I kind of doubt it, honestly. I think
But
that's just how it
I
is.
wish I wish there was a parameter in Copilot that says, you know, don't suggest more than 10 lines of code. Um, right? Because
Yep.
I find it's pretty good on completing one line of code.
Hmm.
And sometimes it can put in a short paragraph of code, right? But anything bigger than that, it's just doesn't get it. There's subtle errors that take me longer to figure out than I could have just written it myself. It's just and it makes me feel uncomfortable and that I have to stare at this code and be very careful and I don't trust it, and so that kind of makes the programming experience just harder for me. So, but I love the short term, the local completions. It's really good at completing, little short fragments of code. It's really good at figuring that. And sometimes it comes up with a good idea. I mean, it's not an idea. It's just a practice that other programmers have adopted that I didn't know about, like some trick, some API that I didn't know existed, or just some cute thing with, using a bit operation here that or an XOR or something tricky. Then, it's just it comes up with tricks once in a while that I didn't know about. And but just little tactical things. I don't like it doing large scale programming. But then everyone says, well, yeah, but in 2 generations and it'll be so much smarter, maybe. But the idea of it auto completing an entire program is just, I don't know. I think there's a lot of hype here. It's really hard to weed
Yeah,
out the hype
it's really hard to
from the
tell. Yeah,
reality.
I agree. Yeah.
So maybe AI, but
Hmm.
I'm just sticking to my guns. What I have to
Hmm.
contribute, if I can contribute something to programming, it's going to be some ideas about how to simplify and how to make languages and databases more powerful than they are now. And maybe AI obsoletes it, maybe it can work with AI. I don't know, but I'm just going to
Hmm.
stick to my guns and keep working on this until until the robots come and kill me.
Well, I think my gut feeling is that your research is so fundamental in a way. Like at such a
Yeah.
foundational level that even if AI like continues this trend, I think it would still be useful. So I think in that sense you
Yeah, that's the
don't.
point you made in your video that it would actually be good for AIs to be able to express programs more simply with fewer tokens, right? If there are fewer tokens involved in programming, then it ought to be able to be good for the AIs too. And yeah, possibly. But there's it's the what was it called? The bitter lesson, that just scaling the training set seems to overwhelm. It's like the bitter lesson of mainstream programming always
Yeah,
overwhelms
I just thought
better
that too. Yeah.
technology, right? It's also just having a lot of examples of crap code to train on is much better than having, a beautiful, powerful programming language with a small corpus to train on.
Yeah, it's interesting. Scale just seems to win, I guess, in at least to a certain extent. Yeah, interesting. Yeah. So a lot of people watching, I guess, they're currently working as programmers, right? So do you have any advice? Is there anything you've observed how people currently work as programmers, where like that's just wrong, or that this is something where that I see all the time that I think could be improved?
Yeah, I would, to young programmers, I would advise that they try to have code, code in the other sense of a moral code, right? That you're an engineer, right? And you ought to have standards, right? Of what kind of work you do, what's the quality of your work, how you make decisions. There's just um, good programmers should have certain standards by which they work, right? And it's not just making money and having fun and um, there ought to be standards. You ought to aspire to be a great programmer means that you have principles and you sacrifice for those principles, that you aren't going to do certain things and you will do certain things even though they're harder, because it's the right thing to do.
What would be some of those principles for you?
Well, I mean, by example, the mistakes I've made in the past have been to invent my own solutions to things, when an off-the-shelf solution is okay, because it's just much more fun to invent your own thing. In my own defense, I was doing this back before a lot of the off-the-shelf solutions existed, so it was kind of okay. Like, I was inventing databases at the same time that Oracle was founded. So, all this stuff wasn't actually off the shelf. But yeah, sometimes I say that I learned the most about programming by carrying a beeper for 10 years. And when you get woken up at 3 a.m. with a bug, right? You learn to appreciate simple code, right? You shouldn't be writing code at the peak of your mental powers, right? Because at 3 a.m., you aren't at the peak of your mental powers anymore. You should be writing code that anyone could understand, right? It's just so simple and straightforward. So simple, straightforward just beats clever. And when you find that you're working on such a clever, beautiful solution to this problem, usually that's a hint that it's too complicated, right? You know, there's a saying among writers of kill your darlings, right? If you're so in love with the way you said this, it means probably that nobody else is going to like it. Um, so it's just but these are things that engineers say. Other kinds of engineers have always said, right? You have, principles in you standards of quality and standards of doing your work. And I just think that programmers should aspire to that also. I think that we should have standards that we stand up for. And think about the future. I mean, I want to put a plug in there that, you got to keep learning new things and be open to new ideas. But it can't just be new for its own sake, right? It should be new because there's a hope that it's going to improve things.
I hear what you're saying. I struggle with it though, because on the one hand, we say that this is such a new field, right? And we don't really know what the best practices are. So I think it's really hard. Like, what are those standards? And like, even with I agree with all the things you said so far. Yeah. So I agree that code should be simple and code should
Yeah.
be
Okay,
like.
here's a real tactical thing.
Mhm,
Comment your
mhm.
fucking code.
Okay, okay.
I can't stand it. I see these code is just like pages and pages of code without a single comment. Like, okay, you're fucking brilliant. I get it, right? You understand what all this is. Are you going to still understand it 5 years from now? When you go back to try and maintain it, and most people are thinking, well, I'm out of here in a year, right? I'll have a new job in a year anyway. So I don't, but yeah, yeah, comment your fucking code. Have some pride in your code, um, and you're doing it's a favor to yourself to comment your code, right? So it's just kind of, and then this is just it's just like this is just like having a clean workspace. It's just basic principles of working that you don't let crap pile up in your workshop, right? No woodworker would, like let their tools become dull and let sawdust fill up the workshop, right? They have standards, and we haven't learned those standards of what does it mean to be a good programmer.
But isn't it that people just disagree? Because, for example, like I don't honestly have a strong opinion on this particular thing. I have strong opinions on other things, but I have on this particular thing I don't have such a strong opinion. But there are some people who have very strong opinions on comments, and they're like, you should write self-documenting code as much as possible, right? Like, so like instead of writing a comment that explains what this variable does, give this variable a name, or this function a name that immediately tells you what it is, because then you also, basically because of the self-documenting thing, you also just have this checked by the compiler if you change the name of the variable, blah, blah, blah. If you have the comment,
Yeah,
then you have to update
they're
the
wrong.
comment.
They're
Okay.
wrong.
Okay.
Yeah, they're
Okay.
simply wrong. I mean, okay, so there are a lot of kinds of programming. So there is the kind of programming where you're implementing a mathematical formula. Okay, if there's a mathematical specification for the function you're writing, maybe you can live without comments, right? Because you already have this very precise statement of exactly what it means. Okay, that's like 0.01% of programming, right? Real programming, we don't have formal specifications, right? The code is the specification, and you just got to explain what's going on here. There's all these abstractions, right? To open up a piece of code that you wrote a year ago, you have to reconstruct in your brain what you were thinking about, and the comments are just super important to explain what's going on. I really can't imagine not needing comments on any kind of other than just completely either mathematically specified or just totally straight line trivial code that's just completely obvious. But in general, you're manipulating abstractions. The language abstractions don't match exactly the conceptual model of what you're doing, and you have to explain that. I don't, I think comments are important. I think comments, the problem is that if you're in a hurry and you're just whipping out some throwaway code, then sure, don't bother with comments. And my problem is that like everyone treats their code as throwaway now. It's like, oh yeah, it's we'll just rewrite it. Somebody else, it's someone else's problem. I'm just going to throw it over the wall. That's the kind of attitudes that, and maybe maybe I'm just old fashioned. Maybe this is the kind of programming that doesn't exist anymore. But you don't produce crap.
No,
Um,
I think that there's some people out there that would argue that writing commented code that is or excessively commented code, maybe they would think what you're just describing is excessively commented code, and they would argue that that is not well designed code that they would like want to rework or refactor or whatever. And I think that's the problem. I think one of the problems is that we can't really agree on what good code actually means. Like if you ask 10 programmers, you get 11 opinions. I don't know, yeah. A lot of these people I highly respect. Like I respect their opinions and they've done provably really amazing things. And then one person says this thing and the other person says the exact opposite thing. And I also don't know what the answer is to that.
yeah, it's true. I mean, maybe I'm being too absolute here. There's a lot of different personality types, and certain styles of working are better for other personality types. The people, so I like statically typed programming languages because it's also a kind of commenting
Me
that
too.
you're saying what your types are,
Yeah.
and they give you tooling assist. I really like the
Yeah.
assist in tooling even more
Yeah. Same.
than the documentation properties. But some people don't appreciate that. Some people just can type really fast, and they're usually Vim users. And and they just don't want anything in the way of their typing super fast, and they're just
Hmm.
like, and that's not the way I work. I like to think things through a little bit more,
Yep.
and so yeah, there's all these perhaps valid stylistic and personality differences. Um, in general, though, I still think that a lot of the time these are artifacts of the technologies that we've chosen.
Yes. Hmm.
So the whole debate about statically typed versus dynamically typed languages, I think that's just an artifact, a historical artifact that it was easy to build these two kinds of languages that in fact there shouldn't be a choice necessary between them, right? We should have types, but they also should be as fluid as not having them. And we should get the tooling. And this is a technical problem that can be solved. We just haven't solved it yet.
And that's exactly what a lot of statically typed languages are moving towards, right? You have gradual typing. TypeScript is the most prominent example.
And that's also why schema change is, to me, a central problem in that I've been working on for many years. Is that so? You have a static type. Databases are statically typed, at least the relational ones are. And well, but then you want to change the type. It should be as easy to change the type as it is to change the code or to change the data. We just haven't built very good tools for changing types. It's really easy to change the type if there aren't any types, which is basically the argument of the dynamically typed people, and that's true. It's because we don't really have the tooling, because the whole statically typed world was, yeah, the types are the brilliant programmer just decided to invent the types, and we'll just assume they're right and never need to change, and we'll super optimize that case. And so they super optimize that case, but it's not the real world. Types change, and so how do you deal with that? We don't have good tools. Type change is something that's just not been very well studied. It doesn't falls between the cracks, kind of our research and our technologies. So that's another thing I'm really into. But I don't know. I just think comments are a key thing. You got to speak to the human, right? The programming language is speaking to the computer, and it also has to speak to the human. And comments really help with that. So, but yeah, maybe I'm just old-fashioned. I like comments because I've been in the situation of having to maintain code that I wrote 10 years ago, and and like I said, and maintain it at 3 a.m. And that teaches you certain lessons, and maybe that's not the world that a lot of programmers are in today. So they've learned other lessons.
How do you feel about literate programming then? About literate programming then? Is
Yeah,
that something
like Knuth's literate
like
programming.
Knut's literate
Yeah.
programming? Yeah,
I mean, it's a great idea in principle, but I just don't see it work. I haven't seen it really work very well. Once again, it's like it seems to me fragile that, if you know the story of your program in advance, you can do this, but you never do, right? The story is changing as you're writing it, and the literate programming seems to prioritize the structure of the story, and therefore you're going to have massive refactoring as the story changes. So, I feel uncomfortable with that, um, for the kind of programming I do. I like adding in the comments into the code. They're intermeshed. Um, there isn't as much of a separation between the narrative and the code.
I see. This is going a little back to what we talked about before. You mentioned before that data is upstream of code, right? And I think I agree with that, and I think that it would be really useful to have, like, for example, that version control idea for data. But how do you feel about this idea, the Lispy idea that the code is just data, right? Because I feel like if we had what you're working on, we could then just apply that same organizational method to the code itself. Is that something you also have in mind?
Yeah, yeah, absolutely. And in fact, that's what I'm working on right now, is adding the code into my current data model of the version data model. Is, of course, the code should be modeled in the data too. I didn't actually didn't when I was going through examples of all the weird impedance mismatches we have. That's a big one too. We model our code either as strings of characters or as ASTs, which are trees, right? Neither of those are very comfortable in with our other data models, right? It should be integrated in. And the problem is, I 100% believe in the Lisp model. The code is data. It just makes so much sense, right? Um, and my intuition now is that the reason I've been unhappy with Lisp and other my own work is that I started from the code side, which just inherited too many preconceptions. So now I feel that I'm starting from the data side, and I'm going to let that tell me how the code should look. And I think it ends up looking really different when you start from the data side. Um, we ASTs were kind of too powerful, that it just lets us add so much syntactic complexity in there, and all of this, syntactic sugar, all these little tricks we've thrown in there to save typing a few keystrokes, right? And, that doesn't have to be the case anymore. And I think having a really simple, I'm starting to wave my hands a little bit here, but what I believe is that code is data, but what's important is that semantics are data. Lisp is syntax is data, right? And that's like the least important unification. What's much more important is if the meaning of the code correlated to the data. So, I've tried a number of experiments. Like, a loop ought to actually literally be a list or an array of some sort. That's what it is, right? It's an open-ended repetitive structure, right? And conditionals, well, what are conditionals? Well, they're kind of like sum types. In functional programming languages, they have different branches, and only one of them is true at a time, is being used. So, I've always been feeling that code data unification ought to result in not just, parentheses being like ASTs, but in that at the semantic level, there's this unification. I haven't pulled that off. And my other story is that calling is like copying and pasting, right? Because it actually can be implemented with inlining, and copy and paste is a form of inline. And so, and I have copying and pasting as a kind of a primitive operation in my data models, my versioning data models. And so that's, approximately not really true, but That's another thing I've been working on is copy and paste being a primitive operation in the data model.
This is the paper where you basically you're replacing function calls, or like really the, I guess almost the definition of a function, with a copy paste operation that keeps track of the code in the two different places, and then you can easily update either place, right?
Yeah, yeah. So it's things are quite different when you look at those kinds of weird unifications. So I'm really into the code as data model. I just think that Lisp, which was beautiful and elegant, especially, having been invented like when I was born, and um, um, is still, though, it was just a first cut, and we could do, there's other ways of going at it, and it's a really hard problem, and I've foundered on it multiple times, and so now I'm, again, like I explained, trying to switch it up and start from the data side as something that at least give me some direction and principles and guardrails kind of to lead it, because let's face it, I'm sort of stumbling through the dark, and all research is kind of like that. You're stumbling in the dark, and finding some kind of guardrails or some path to lead you can really help, I think. So I'm data is upstream of code is my new slogan to try and give me some direction.
I think it's a really promising direction. To me, at least, it sounds like that. There's this discussion going on about should you write functions that are only called once ever, or should you just write that code in line and maybe add a comment on top explaining what this block of code does. And then there was like this post by John Carmack, where he like talks about this, and he actually argues for inlined code. So essentially what he's saying is generally don't write functions that are called only once. And I found that empirically to be true. I found that this results in more readable code, because while yes, it makes the current function that you're working on longer, it decreases the overall surface area of your code, and thus the overall complexity. But then at some point, when you actually do want to reuse that code in some place, you have to like create a function from it. But I'm wondering if there is a language possible where you don't even have to do that, where basically you can click a button and the code is either inlined or not inlined.
Yeah, well, that's what I've been trying to do. In fact, I've had a number of over the years tries at that idea, and I'm totally with Carmack on that. Um, and more generally, um, I've talked a lot about complexity in terms of just stupid reproduction of stuff, but the other dimension of complexity is unnecessary abstraction, right? It's adding these layers of abstraction of don't repeat yourself. Anytime anything that looks similar, you should abstract that out into one place, and that's just crazy. That just adds so much complexity to understanding the code, and literally, if there's no call for a function if it's only used once, right? But like you've already gotten there. But what I'm saying is that it would be nice if there's a language where there's no difference between using a function once and inline, or defining a function that you call once. It's actually the same thing. It's you define your functions in place to start with, and then you can abstract them out or just reuse them. And if you use a function twice, it's also not clear that that isn't just sort of like one of my copy and paste relationships. Like, copy that code into another place and just remember the fact that you copied it so that you can maintain the code, and that could be better than having a proper abstraction. I mean, proper abstractions are always better if you have infinite intelligence, right? And infinite concentration, but we don't, right? And in fact, that's what we have to budget, is the amount of abstraction in our code, because we're not very smart, really. We can only remember 7 things at once. We're pretty limited. And it's a real struggle to be intelligent and logical, and we have to budget our cognitive cycles, right? And on what's important and what's not important. So, um, But yeah, abstraction is a key thing for me, reducing the need for abstraction and just most importantly, giving it a price, right? Don't assume that abstraction comes for free, which is the principle of a lot of computer science and like particularly like people in the Haskell camp, right? It's just like, oh, they're mathematicians, they're so brilliant, right? And they can just think at this abstract level, and and maybe they are, but it's just the rest of us stupid people. And when I
I
say
can't.
stupid
Yeah.
people, I'm actually pretty smart by objective measures compared to most humans, right? But even programming makes me feel stupid, if I'm honest with myself. So I don't want to make it require more intelligence. So yeah, getting rid of abstraction. So functions are,
Could it also be part of this problem with the functions? We're using the same tool, functions, to solve multiple problems, different problems. Because one, like the reason why some people say, yeah, you should create functions even if they're not called in multiple places. One of the reasons is it allows for reuse. We can call the function in multiple places. But the other reason is just the chunking of that piece of code, right? It's basically like a way for us to think at a higher level of abstraction where we think about this piece of code as just one symbol, essentially the function name, right? And then if you have this symbol internalized, you don't have to think about the individual steps in that piece of code. But my gut feeling is that it's incorrect that we're using the same tool to achieve those two goals.
right. I mean, chunking is something, but there's just all these intermediate partial forms of functions that I think are really useful that are being left out. Code folding is another kind of chunking, right? Where you can just say, okay, just collapse this bracket stuff because I kind of know what's inside there, and hopefully there's a comment on top of it that says what's going on there.
So you mean
That's
like
kind of,
in the IDE, just, or like in
yeah,
the
right.
editor,
Yeah,
just
yeah, right. Code
folding
folding in the editor. Yeah,
collapsing the block.
yeah.
Yeah.
So sticky code folding, right? That's kind of chunking at that point, right? So, you know, and then like you were saying before, the step from there to a declared function is that you put a name on it. So putting a name on something is really useful. It's not just an anonymous chunk. Now it's a named thing. And to me, names are super important, right? So, you know, which is why I refuse to program in any environment that doesn't have a rename refactoring, right? This is why I like type systems, right? I'm always renaming things as I change my understanding of them. I want the names to be accurate. So I want refactoring to be fast and perfect. So, but like you said before, I think you should just push a button at that point and it pulls it out into a function and then you fill in the name, right? Um, and going back to the inlined version of it should be the opposite of that button, right? It should be very fluid. And it would be nice if, in fact, that wasn't even a change to the code,
Yes.
right? That's just a
Yeah.
change
That's
in
the
the
key.
view of the code, right? It's like code folding, only it's cross file or cross something, inlining folding, right? It's all just part of the visualization you've chosen, but underneath it's still the same.
To me, that feels like such a promising idea. Yeah. That the key thing is that it's not an actual change. It's just a way to view this. Yeah.
Right. And then we have some sort of simpler universal representation underneath that doesn't have all these asymmetries, right? It's just a much simpler, more symmetric representation. And again, that all gets back to what's the data model for code. It should support that. I also like to really encourage people to, explore these intuitions and try and work on improving programming because it could be so much better, right? I mean, that's the thing about programming. It's like it's you have the power of a god, right? Because you're creating an entire universe, right? And seeing it work, and it's got all these little beings in it, right? You're God, and yet you're a god who spends all their time, like, in the latrine cleaning out the shit, you know? I mean,
Yeah.
it is just so much grunt work and disgusting
Yeah.
and just terrible, and so
Yeah.
we have to reconcile this
Yeah.
and so I just encourage everyone who is tapped into these
Hmm.
feelings of there's something wrong and it's our job to fix it and we have
Yeah.
to work on that and we have to get together. and jointly pool our energies and resources because it's not going to happen. No lone genius is, I hoped, when I was younger that I would be the lone genius. Everyone has that dream, right?
Yeah.
But I've given up on that. I realize it has to be something that people come together as a movement,
Yep.
as a field. And we all, none of us can figure it out. We're all going to have to stumble through, but by helping each other and competing with each other, um, we can make progress. That's how progress actually happens. And I'm taking another run at this. I've tried repeatedly this try to rethink the notion of functions because that's sort of the central theoretical abstraction, right, in programming languages, this function calling. And I have this strong intuition that we're doing it wrong. It's over abstracted. It's an idealization, and we don't need that idealization given that we have fancy programming environments now. It's not just textual, but it's hard. I've failed repeatedly to pull it off. The details keep not working out. I mean, it starts as an okay idea in a vague sense, but then you get down to the details, and it just starts getting messy and you just start getting this feeling, this is not working. And so I'm gearing up here to take another run at that.
Man, I
But
can't, honestly, I can't wait to see what you come up with. It sounds really great.
thanks.
Hey, thanks for watching. If you enjoyed this conversation, please consider sharing it with a colleague or leaving a like and sub. Also, you might be interested in my interactive Git cheat sheet. Link down below. Have a great day, and thanks for watching Philomatics.